Hi everyone, in this video we are going to solve trigonometric equations using identities. So let's look at example 1. The function m is given by m of x is equal to cosine 2x plus 4. Find all input values in the domain of m that yield an output value of 9/2. Okay, so what we're going to do first is we're going to set cosine of 2x plus 4 equal to 9/2. Now notice you see that it's cosine of 2x, which is a double angle formula, but we're going to do this example without replacing cosine of 2x. You'll see what we're going to do here. So I'm going to act like it's a normal equation. I'm going to subtract the 4 over. So I have cosine of 2x is equal to, I have 9/2, and then I'm going to switch 4 into to be fractional with a denominator of 2, which would be 8/2. So then 9/2 minus 8/2 is just 1/2. So I have cosine of 2x is equal to 1/2. Now I'm going to say, let's say a is equal to 2x. So I'm going to replace a in here. So I'm going to have cosine of a is equal to 1/2. Now we definitely know that from our unit circle that at pi over 3, I have the coordinate 1/2 radical 3 over 2. Remember, your cosine is your x value. So at pi over 3, I have 1/2. But again, let's go through what our signs are in each quadrant. So where else, other than the first quadrant, is cosine positive? Well, it's also going to be in the fourth quadrant. Okay, so that would make it 5 pi over 3. Okay, so I have here, I have pi over 3 and 5 pi over 3. But that's when it's a. But I really don't have a, I really have 2x here. So what I'm going to do is I'm going to do 2x is equal to pi over 3 plus, again, it wants for all input values in the domain of m that yields an output of 9/2. So we're going to do plus 2 pi k, where k is an integer. And then also 2x is equal to 5 pi over 3 plus 2 pi k. So now we have to get x by itself. So that's the easy part. We're going to multiply everything by a half. So the left side gets multiplied by a half, the right side gets multiplied by a half. So this entire thing. So I'm going to get x is equal to, well, 1/2 times pi over 3. So I'm going to have pi over 3 times 2 is 6, plus 2 pi k times a half is just pi k. Now we'll do the same thing to the other equation, multiply this by a half and this by a half. So I'm going to here have x is equal to 5 pi over 3 times 1/2 is 5 pi over 6 plus, again, pi k, where k is any integer. And that's my solution. So again, notice that we did have cosine of 2x, but we really didn't replace it with any of our double angle formulas. All that we did was save it for the very end, make a is equal to 2x, solve for a, figure out which angles they are, pi over 3 and 5 pi over 3, then replace in the 2x for a, then multiply by 1/2 on both sides, and you end up getting your answer. For the next question, number 2, the function m is given by k of x is equal to sine of 2x plus radical 3 cosine x. Find all input values in the domain of k that yield an output value of 0. So just like the last question, I'm going to set k of x equal to 0. So I have sine of 2x plus radical 3 cosine of x is equal to 0. Now this time I'm going to replace where it says sine of 2x, I'm going to replace that with one of my double angle formulas, which is going to be 2 sine of x cosine of x. And then bring down the plus radical 3 cosine x is equal to 0. Now this becomes a factoring question. Notice that I have cosine of x in both terms, so I'm going to pull that out like a GCF. So I have cosine of x, open parentheses, 2 sine of x plus radical 3 all equal to 0. Then when I have this, I'm going to tee it off like I normally do. So I have cosine of x is equal to 0. And then here, I'm going to have 2 sine of x plus radical 3 is equal to 0. So I'm going to subtract over the radical 3. So 2 sine of x is equal to negative radical 3 divided by 2. So what I'm going to have now is I'm going to have sine of x is equal to negative radical 3 over 2. Okay, so let's start with the left-hand side. So at what angles does cosine of x give us 0? When is cosine 0? Well, again, think back to your unit circle, right? So this is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So where am I at 0? For cosine, which is your x value, at pi over 2 and 3 pi over 2. So x is going to be pi over 2, 3 pi over 2. Okay, and what about when x is equal to negative radical 3 over 2? Well, think back at when I have pi over 3, right? I have 1/2 radical 3 over 2. So sine is my y value. So radical 3 over 2 is positive, but I'm looking for the negative. So again, if we draw out our quadrants, and positive, positive, negative, positive, negative, negative, positive, negative. So where am I negative? Well, I'm negative in the third quadrant and in the fourth quadrant. So again, using pi over 3 as my reference angle, my third quadrant is going to be 4 pi over 3. And my fourth quadrant is going to be 5 pi over 3. But again, like the last question, it's asking for all input values in the domain of k that yield an output value of 0. So our answer is, our solution is going to be x is equal to, I'm going to take pi over 2 plus, noticing that this here, when cosine of x is equal to 0, it's happening twice in 2 pi. So I'm going to do pi over 2 plus pi n, where n is any integer. And then x is equal to 4 pi over 3 plus 2 pi n. X is equal to 5 pi over 3 plus 2 pi n. Again, where n is any integer. And those are my solutions. Our next question, number 3, where are all values of theta for 0 less than or equal to theta less than or equal to 2 pi, where 4 sine squared theta is equal to 2 sine of theta? So the first thing I'm going to do is I'm going to subtract over my 2 sine theta. So I'm going to get 4 sine squared theta minus 2 sine of theta is equal to 0. Again, very similar to the last question, notice that there is a sign in both terms. And actually, there's also a 2. So my GCF here is going to be 2 sine of theta, open up parentheses, 2 sine of theta minus 1. So there's 2 sine of theta in both terms. That's why we pulled it out as our GCF. Then I'm going to tee it off like normal. So I have 2 sine of theta is equal to 0. Divide by 2. I get sine of theta is equal to 0, which we should know that sine is 0 at 0 pi, 2 pi, and then 2 sine minus 1. I'm going to set that equal to 0, add over the 1. 2 sine of theta is equal to 1, divide by 2. I get sine of theta is equal to 1/2. Okay, so let's think back to our unit circle. At pi over 6, I have the coordinate radical 3 over 2 and 1/2. So sine, remember, is your y value, that's 1/2. Again, let's draw out my sines in each quadrant so I can figure out when sine is positive. So let's see. Sine is positive in the second quadrant and obviously in the first quadrant. So we know pi over 6 is one of them. Then the other angle has to be 5 pi over 6 in the second quadrant. So which one's my answer choice? It has to be B. 0, pi over 6, pi, 5 pi over 6, and 2 pi. Go to the mixed practice questions now and answers numbers 1 and 2. Pause the video now and try them. Now, I hope you notice for the first mixed practice question, when you see m of x is equal to cosine of 3x, now we have our double angle formulas, but we don't know anything with 3x. So you begin to freak out saying, I don't know how to do this. But you do know how to do this based on the first example we did in this video. So for number 1, make a equals 3x. So solve it. So set it equal to 1/2. So cosine of 3x is equal to 1/2. If we make 3x equal to a, cosine of a is 1/2. When is cosine 1/2? At pi over 3. And at 5 pi over 3, set that equal to 3x. And then to get x by itself, you multiply by 1/3 on both sides. So everything gets multiplied by 1/3. So then your final answer should be x is equal to pi over 9 plus 2 pi k over 3, or x is equal to 5 pi over 9 plus 2 pi k over 3, where k is any integer. And think about that logically. If your frequency is 3 and remember your period is 2 pi, so 2 pi over 3 is where you get that. Let's look at the second question. So the second question we had secant squared x plus tangent x. Well, secant squared x, I don't want to solve for secant and tangent at the same time, so I have to replace in. So I know one of my identities. I know that secant squared x is equal to tangent squared x plus 1, so I replace that in. I want to work with only one trig function. Once I do that, subtract over the 1, the 1's cancel out. I want to factor out a GCF of tangent of x. So tangent of x times tangent of x plus 1. I get tangent of x is equal to 0. Tangent of x is equal to -1. Remember that tangent is really sine over cosine. So when is it 0? At 0, 2 pi, and pi. And when is tangent of x equal to -1? That would be at 3 pi over 4 and 7 pi over 4. So continue with the mixed practice problems, and I will post the answer key later today. Thanks.